Okay, good evening. My name is Mike Whisonant. Work for Marietta in Dallas, Texas. So it's a little bit different here than it is at home right now. We have about 100 ready-mix plants. We do about 6 million yards of concrete a year. So I get to deal with cracks all the time. Part of the fun of the job. So, but is it possible for the concrete producer to produce crack-free concrete? We've got a spec up here that says it has to be shrinkless, non-cracking concrete. How many times does someone see that come across your desk? Well, I guess let me ask this before we go on. How many guys are concrete producers? So 3 or 4 of us? Okay. So I can make it to the door, I think, if I fish you out too much, right? So, is a concrete producer responsible for cracking? Is it possible to produce it without cracking? So here's a ready-mix plant. We all have seen these before, right? I take it? So in these plants, we usually label the bins. So we got 57 limestone, put some natural sand, and of course the crack bin. And then over here we got our cement and cracks in that silo. So do you think we actually put cracks in the concrete before it leaves the plant? No. Do we have the potential of making concrete that can crack at the plant? Sure. So if we put in more sand to help it pump, how is that going to affect the concrete? Water demand, increased pace, all those kind of things. If we put in more rock to help reduce cracking, what's going to happen? It's not going to pump, it's not going to finish well, all those kind of things. So we have to find that balance. Same thing with the cement. If you put too much in, you're going to crack. Not enough, it's going to crack. So in a broad perspective, though, cracks form in concrete due to one or more of the following. Stress, not controlled by me, right? Subgrade issues, not controlled by me. Weather conditions, not controlled by me. Thermal. Now, I was in ACI 207 this morning. I'm a member of Mass Concrete. I don't want to talk about thermal cracking ever again, but it's part of the committee meeting up there. We just talked about it in 301 not long ago. So we're not going to get into thermal today. So non-shrink concrete is really not possible with normal Portland cement. Now we can get into type K and that kind of stuff. That's a whole other discussion. But for ordinary Portland cement concrete, you're not going to produce crack-free concrete, non-shrink concrete. Can produce low drying shrinkage? Sure. But how low is low enough? You give me some shrinkage number. Is that going to guarantee that you're not going to have cracking? What is that magic number? And are all cracks caused by shrinkage? Pretty much no, right? So, some repeated advice you'll always see, whether it's in design and control of concrete mixtures or any other references out there. First, with the least amount of water possible. But remember, the contractor wants workability, right? So you can add high range, you can add all that kind of stuff. But some water reducers actually cause shrinkage. And we'll get into that later if you want to. More bug your admix supplier if you want to do that. Portion of the mix with the least amount of cementitious material as possible. Now, being a good ready-mix producer, I'm not going to put any more cement in there than I have to, right? What's the point of that? So I want to make sure that I'm going to get the right amount of strength guaranteed to my customer without over-cementing it. Portion with the largest practical aggregate size. So if you have this kind of reinforcement that you're going to put on there, what size rock are you going to put in there? 3/8, right? How much do you think that's going to shrink? A lot, right? So the smaller the rock, the more it's going to shrink. So reinforcements can dictate more shrinkage just by its nature of being so close together. So who's responsible to determine the properties of the concrete mixture? Went too far. Okay. So we can produce low shrinkage concrete if you have enough money, right? You pay me enough money, I'll give you a good mix, but it's going to cost you. Shrinkage is affected by available concrete mixtures and ingredients, so there are rocks that shrink more than others. There's more sand that can contribute more to that. Is there other objects in concrete that can increase shrinkage? So you're going to bring in stuff from farther away, it's going to run up costs, all those kind of things go into it. But most projects don't have the budget to bring in concrete mixture ingredients from out of the area. So I'm not going to rail in granite from South Dakota to Texas because you want a granite material unless you're willing to pay for it. It's a whole different story. Shrinkage additives may reduce drying shrinkage, but they're not cheap and may cause other issues. One of them is, whenever you use a lot of shrinkage reducing products, you'll lose strength. So what do you do to combat losing strength? Put more cement in, right? You put more cement in, what happens? It shrinks more, right? So you're in this circular pattern of problems. So it's something to remember when you're dealing with that. So this happens to be from one of the projects that I'm working on right now. It says maximum cement contents determined from the maximum water cement ratios. The maximum water contents given in the concrete property tables below are intended to minimize drying shrinkage and heat hydration. So if I design a mix that meets all these criteria, is it going to minimize cracking? Are you going to guarantee low shrinkage? Just I produced it that way? So if I do it and it still cracks, who's responsible? Is it me or the engineer? Good question, right? Well, this is another part of the spec. Maximum concrete shrinkage for specimens cast in the laboratory from the batch will be measured at 21 days, 28 days at 0.036 and 0.042 respectively. But also, maximum concrete shrinkage for specimens cast in the field shall not exceed the trial batch maximum drying shrinkage by more than 25%. So that means that I cannot have more than 0.05 in the field, right? So how you read it? Is that how everybody's reading it? ASTM C157, which is a shrinkage spec, field cast specimens can show up to twice as much drying shrinkage as laboratory cast specimens. So, if I have to keep it below 0.5 in the field, what does my lab concrete have to be? 0.025, right? So then I'm getting more and more things that are costing more and more money. You get somebody who's giving a concrete that may or may not shrink still, may or may not crack still. So, what is real? So this is a particular set of materials that I have in Texas. I ran different water cement ratios versus shrinkage, and just as everyone suspects, the more paste that you have in it, the more shrinkage you're going to have. That's not a shock to anybody, right? So we want to find ways that we can reduce the amount of shrinkage, but have enough cement content in the mix to make strength. So it's one of those competing factors against each other. So this is another one. It says concrete shrinkage limit shall be as followed. All concrete designed as low shrinkage shall utilize concrete with shrinkage of less than 0.02% at 28 days. 0.02%. Over here, what I just show you that probably the lowest I can get down to is about 0.03. So if somebody says that they want 0.02, is that going to happen? Not to say it's impossible. It's difficult with these materials without adding a bunch of extra cost. So all the concrete used for suspended slabs utilize concrete with 0.035 at 28 days. We can do that, depending on how much strength that you need. Now, if you're worried about these, that it's going to be on a suspended slab that you're going to strip early, what's going to happen? You're going to put more cement in there to strip early. So are you going to make the 0.035 then? Maybe not. So what's more important to you at that point? So here's another one, a lot of reinforcement, right? So again, we're dealing with very low shrinkage values for very small areas. So you're going to guarantee problems here just because of how much paste is shown here. So what happens on the job? So my truck goes to the job. That's my PowerPoint skills. Everybody. This is a automated slump control system that we have in our trucks. You can tell as he leaves the yard. I don't know where the. Oop, no, it's not what I wanted. I don't know where the laser is on this. But anyway, you can tell that he's right at slump when he leaves the yard. He shows up on the job site. Guess what? A bunch of water's added on the job site. So what do you think is going to happen to that concrete? Especially since it was supposed to be a 6 and they poured out a 9. What do you think is going to happen to that concrete? It's going to crack. I guarantee you it will crack. So we know this. Yet we do it all the time, right? So you got to decide what's more important at the time. So how's weather play into it? We've all seen this little graph, right? Someone familiar with this pretty little graph? Essentially, it's a way to predict whether or not you're going to have plastic shrinkage cracking. It's debatable how accurate it is. I think it's pretty darn good, but some people disagree with it. I will tell you, being in Texas, that every day there's potential for plastic shrinkage cracking. High winds, low humidity, high temperatures, you will get plastic shrinkage cracking. And it looks like that. Is the owner going to be happy with that? No. Is that cracking responsibility of me? The responsibility of the contractor? The engineer? Who's responsible for that? So, what's the producer supposed to do? So, remember the repeated advice? Force the least amount of water possible. I will do that. I will make sure that there's no more water in that mixture than there has to be. But that may result in lower slumps than what you really want. Force them with the least amount of cementitious material possible. I'm going to do that all the time. I don't like giving away cement. Although I'll tell you, I have cement responsibilities and I have ready mix responsibilities. So I have this constant urge to make sure my cement guys are taken care of as well. Force them with largest practical aggregate size, which showed all those reinforcements so close. And ensure concrete is strong enough to avoid the tensile strength forces early. So, if it's wintertime, like today, and you pour concrete, and you're going to strip those forms tomorrow, what do you think is going to happen on that surface of the concrete? There's not very much tensile strength, so it's going to crack, right? So, to fight for economy, quality, and design, just like the triangle we just talked about, right? Cause all these things to be slighted. So poor design requirements will cause the concrete cracks. Specification requirements can increase the cost of concrete mixture. Poor application procedures will cause the concrete to crack. And poor quality of mixtures or applications will cause the concrete to crack. There's a lot of things that go involved in it. So cracking is a very good potential a lot of times. So adding chemicals, high ranges, may actually increase shrinkage a little bit. Shrinkage reducers will reduce strength or increase cementitious content. Expansive cements will increase form costs, will require more labor to produce, all those kind of good things. Proprietary admixtures can be a challenge to produce. I won't go into all the brands, but they all require special things. And fibers can increase water demand due to perceived workability loss. So if you increase water demand, what happens? The more shrinkage. So if the fibers aren't able to withstand that shrinkage, you're still going to get cracked. That's all going to cost you money, right? So the next wave of things, and don't get me wrong, I want to make this statement very clear. I am not against measuring the GWP, making sure that we're more carbon sensitive, all those kind of things. I'm not against that at all. But I will say we have to remember this. If we reduce GWP, what's the best way to reduce GWP in a concrete mixture? Reduce cement content, right? So we reduce cement content, what do you have to replace it with to make strength? Ash, slag, those kind of things. What happens to early age strength when you have higher ash content? So say you're running 40% ash. What's going to happen to your early age strength? Tensile strength especially. It's going to be very low. So what's going to happen to the concrete? It's going to crack, right? So we have to keep that in mind as we move forward. So in short, there are things a designer can do, all of which cost money. There are things a contractor can do, all of which cost money. There are things a producer can do, all of which cost money. So the producer limit is the technology, dedication, and knowledge that we really need, and a reasonable expectation of everyone that's involved. That's really what it comes to. All we can do is proportionally deliver concrete mixtures that have been specified and agreed to. Pretty simple, right?